Here we have a two-part problem. In the first part, we're going to determine what value or values make the denominator 0 in the equation. And what we want to do is keep in mind that if, when we finish solving the equation, one or more of those values are part of the solution, then you have to remove that from the solution. You're not allowed to use anything that will make the denominator 0 because, of course, that will make the fraction undefined. So let's take a look at this problem. We have 2 over 3x plus 1 over 4 equals 25 over 6x minus 1 over 3. And I'm going to look at the denominators. I have two denominators that have variable expressions in them. So these are the ones that I'm going to look at for restrictions. If we have a denominator with no variable in it, we don't need to worry, it can't equal 0. So let's put our restrictions here. And I'll start with the 3x. If that equals 0, that means that x must equal 0. And same thing for 6x. And obviously, these would give you the same result, which is 0. And I didn't show that I divided both sides by 3 and I divide both sides by 6. But I think you're ready to just go from 3x equals 0 to x equals 0. So what is our restriction? Our restriction is x cannot equal 0. If we get 0 as a possible answer, we have to remove it from the solution set. Okay, so now I'm ready to start solving this equation. I have x cannot equal 0 under my restrictions. So what I'll do is I'll look at my equation and see what can I multiply both sides by to eliminate the fractions, because it's a lot easier to solve this if we don't have fractions. So I find the least common denominator, even though I'm not going to change the denominators. So off to the side, I'm going to say my LCD is going to be what? Well, I need a number that is divisible by 3, 4, and 6, so that would be 12. And it also needs to have an x in it, so 12x. So 12x is my least common denominator. Now I want to take this least common denominator, and instead of changing the denominators, I'm going to multiply every term in the equation, regardless of whether it's a fraction or not. Now in this case we have 4 fractions, but if I had a term that wasn't a fraction, then I would still multiply it by the LCD. Okay, so I'm going to spread my terms out. Let's see, leave a little space. So when you're setting this up, especially when you have rational expressions, it's nice to leave space between your terms, and that leaves you room to manipulate. So I have 2 over 3x, and that's going to get multiplied by 12x, and that's 12x over 1. And then I do the same thing to the 1/4, and the 25 over 6x, and finally the 1/3. It's a little squished in there, but it's all right. And now I can simplify. 3x divides into 12x 4 times, and 4 times 2 is 8, plus 4 goes into 12x 3x times. I don't like to just cross out the 4 and the 12 and write the 3 above. A lot of times you forget that x, at least I do. So just bring it along, and that way you don't get mad later when you realize you have to redo the problem. So we have 3x times 1, which is 3x. And this equals 6x into 12x goes twice, and 2 times 25 is 50, minus, and 3 goes into 12x 4x times, and 4x times 1 is 4x. So now I have a regular linear equation which you probably don't need any help solving. I'm going to solve it real quick here and add 4x to both sides, get my x terms together, and at the same time I'll subtract 8 from both sides, and so I get 7x equals 42, and when I divide both sides by 7, this gives me x equals 6. Now, don't forget at this point I have to look, was 6 one of my restrictions? It was not. That's my only solution. That's my final answer.